What's up?
Not too much, not too much. It's nice to meet you.
Yeah, nice to meet you too. So I'm just gonna start. I'll just present myself because I think you should know. So I'm Dean. I'm from Wix's performance infra team. So we do here infrastructure performance features, and right here beside me,
Hello.
this is Sheer, and she's from Wix Academy, and she helps us doing such stuff, which is super cool. So we want to hear a little bit about yourself. So would you tell us?
Yeah, so I'm a principal engineer. I work over at Lululemon. And I mostly work on a lot of open source initiatives. So Webpack, probably the biggest thing that I work on regularly, or the ecosystem that leverages it. And then other things that, I generally involve myself in are a lot of web performance things as well. So runtime performance, load performance, managing third-party code, code orchestration, distribution of runtime, stuff like that. Anything around like how do I get a large app to run more efficiently, and how do I reduce the overheads that teams have to carry.
Cool. So we do similar stuff. So how did you come to be a Webpack maintainer?
I believe it started probably around 2015. We had, I don't know if you're familiar with the React server-side rendering stuff, and so like there's two separate builds, and all of that kind of creates it, and you correlate the server build to the client build, and that's how you server-side render all your chunks out. So I was originally involved in the first project that achieved that in React code. Um, and part of that was a Webpack plugin for CSS. And we kind of would figure out when the CSS for the chunk loads and when the other scripts for the chunk loads, and then we would actually, make the page hydrate when those modules get loaded. Over time, what we ended up doing was just adapting that to run on its own. And the big thing that it had was hot reloading, which many CSS didn't have at the time. And so how I ended up actually getting involved with the Webpack Foundation was I ended up merging that project with mini CSS to bring hot reloading and a couple other features to mini CSS. And from there, I just continued more working with Webpack and more of the dependencies from there. But yeah, I've always just had an interest in compilers. There's just a lot of power that you can augment from them that you would usually struggle to try and implement higher level, like in a framework or in an engineering pattern that you can kind of automate to some extent through the compiler.
Awesome. So compilers just got your attention, right? So
Yeah.
we'll talk about it in a sec. But let's start about the main focus of our talk, model federation. So how would you explain the feature?
I would say that module federation it's a way to import pieces of code from independently deployed applications at runtime. So if I wanted to say import a feature or share a dependency between two standalone applications where there's the ability for them to overlap, let's say they're both React applications, something like that, they could share one single dependency of React, or the big one was if I'm building out microfrontends or something like that, and I need the ability to just import a feature or an actual component that another team owns. Instead of having to go over NPM, I could just import it at runtime through module federation.
So as you see it, it's a solution for scaling problem or a solution for performance problem?
I would say that the performance is a side effect of the design, but it was mostly geared for a scaling issue.
Cool. So how did you come to figure that such a feature is needed? What was the real world use case? So it got
Yeah, I was working at Fiverr at the time, and we had about 150 microfrontends that we had to manage. And we were managing them with like, Webpack externals, so Redux, React, put it in an external chunk. We had some challenges when we would go from like React 15 to React 16 at the time. How would you get an external vendor chunk with two different types of React in it? If the external chunk goes missing, the pages stop working. It was very brittle kind of solution, especially when you scale it up. Um, it wasn't elegant, but there was no better solution really out there at the time. So that's what kind of got me thinking that, there must be some way where I can just import the 20 kilobytes of code that I actually need from this bundle because I already have React or already have Lodash or already have, 80% of whatever else I need. If I just want that 20 kilobytes, that's the page code or the feature code, there must be a way to import it. And so that's kind of what started the journey off, thinking late 2018. That's when I started to really research it. And it took about 2 years to actually get something out there.
amazing concept, amazing implementation. It's like I'm impressed, honestly. Uh, so
Thank you.
so there's a lot of solutions like monoliths and like monorepos, and I recently found out there's a concept called virtual monorepo, which you get like the Git feature of submodels and like do a submodel of Gits and having a Webpack that aggregates every other Webpack in order to solve that exact issue. What do you think about such solutions instead of model federation?
I think that there's still, even with monorepos, you still have the like there's two or three challenges that have cropped up for me around them. Like one is there's still the bottleneck of there's just a single branch. So even if you solve many other things, you still, if you run tests or something like that, like we saw this on one repo we had where there were about 800 deploys a day to it, and the tests take about 15 minutes. So you're sitting there like updating the branch, trying to get your test to pass before the next merge comes along. And you just get stuck in this loop where it could take like an hour to actually merge the PR if you're not watching it the whole time. So I do think that there still are some challenges around the monorepo space, just in terms of the actual bottlenecks that you get in the merge pipeline. But like I use a mixture of it. So I still use federation, but I also use monorepos. And what I try to do with them is create kind of a construct that's like a sub app system almost. So I have like a server instance or something, and then I'll have the sub applications that live on it in the monorepo. And that lets me kind of scale horizontally and vertically, because once that repo gets too large, it's already set up kind of like a package internally. So I can easily move it into another monorepo or an empty monorepo and just keep on developing inside of there, because everything is kind of structured to be somewhat independent. So it lets me, increase the size of the repo, quickly add more teams onto an existing infrastructure that we have. But if I need to split it up, it's still kind of designed to be split up, and go off into the more granular multi-repo approach. So that's mostly how I try to gear it, because I found that the monorepos in general, even if I use something like, say, I use a rush stack on a couple things, which is quite nice for like versioning monorepos and managing change logs and running builds and finding the diffs. But still, it takes a lot of time to run part of the pipeline. It's not extremely fast, and if you have a lot of tests on there, it can just get slower. So still, I haven't found a truly scalable solution that's not expensive to implement, that could solve, 50 teams working on a single repo. It's still haven't quite found something. So often go for the kind of multiple repo solution.
Let us know when you find one. So about model federation, would you say there's a difference between backend usage of it and frontend?
Um, not not entirely. I think that there's more immediate use for the front end because that's where we've historically had the limits around bundle size or how something's bundled, and it can only be done in a specific way. On the back end, we have more luxury around not having to worry about the latency issues as much. Or it's easier to do microservices in the back end because bandwidth isn't a major problem. You can just set up another container with all the dependencies and it's running. So how the actual mechanics of it work, though, are pretty much the same. Like if I do server-side rendering or something like that through Federation, it all works the same. But backend wise, there's definitely some very interesting things that you can do with it. Newer patterns that come out. Things like you can stream the code from, say, GitHub's API if you wanted, directly into a backend service and not have any S3 buckets or any like kind of deployment stage. It could kind of be transparent directly from GitHub, and Webpack can read that code in runtime right off of the GitHub API, which offers some very interesting like deployment mechanisms and things like that. I think also like the ability to use Federation with WebAssembly has some pretty interesting opportunities for like polyglot development and orchestration of polyglot code.
Cool. Would you say there's a like a use case where you should not use model federation?
I would say probably don't want to do it unless you have a need for it. Just like with microfrontends or anything else, unless you have the scaling challenges where you actually need federated code, it's not something that you want to necessarily add on as an overhead. What I would suggest is if somebody thinks that they might, to try and just design the application to be self-sufficient or not to be heavily bound, and then at a later stage decide if you actually need federated code. And if you do, then it won't be as much of a challenge to handle the architectural changes needed to kind of support how Federation can dynamically load different parts of your code. When you kind of have like a wrapping application or something like that, we generally develop a lot of dependencies higher up the tree. If we're talking about React, you could have providers or something like that. But what happens if you're pulling in a component to an app that doesn't have those providers at all? And there's no way to encapsulate it. So you kind of want to bear in mind some of those patterns when developing a federated app.
Yeah, because it can give you a blind eye about this stuff.
Yeah.
So you talked about the compilers. So there's a new thing on the block, which is called YesBuild. Can you share your opinions on it?
I'm a big fan of YesBuild. We actually got Federation working on YesBuild partially, but YesBuild is really quick. Like I've enjoyed it a lot when I need something fast. Even using Webpack, I often swap out Babel with the YesBuild loader, just because it's efficient, it's fast, and it's really nice to see tooling go beyond JavaScript. That does create some kind of like accessibility challenges for general JavaScript engineers, but I think it is a good step for some of these lower level tools to consider taking, just to capitalize on the performance and the multi-threaded capabilities that other languages have more out of the box.
So you don't use YesBuild as a standalone tool. You use it as a loader from Webpack, right?
Yeah, everything I do is Webpack based, just because generally anything that I'll do, I need more flexibility. And I think like often Webpack kind of gets lumped in as like it's something that spits out JavaScript, and you kind of think it almost like a Babel with a couple extra features or something like that. But the reality of them is like a lot of these bundlers or transpilers, they just handle converting the code at some speed, where what I'm mostly leveraging in all of my work is the orchestration of that runtime that they have on top of them. So something like YesBuild is really good for doing a one-to-one translation, but it doesn't have a parser that's accessible, or like a dependency factory or anything like that. So all I can do is I can do some plugins and things like that, but I can't create complex rules or orchestrate a runtime easily just with the YesBuild.
Cool. So let's answer my question about do you think it's easy to an alternative for Webpack? Cool.
It depends. It really depends on what you're trying to do with it. If all you need is something to build code, then happily. But if you have really complex requirements, or you want, any kind of orchestration, it gets a little bit more complicated to do it without the help of that extra API layer that Webpack has.
Cool. So there's a different feature which is called a library which is called loadable components, which actually loads lazily components, React components. So basically, it does the same stuff as model federation. Why wouldn't you include the API of loadable components and like achieve that as well?
So loadable components works inside of an application where it already has access to the Webpack chunk graph. So the big challenge that we have with federated code is you don't know, or you don't have access to their Webpack graphs when you're executing that code, or usually, or you would need a way to like manually go and loop the graphs together. And that's one of the reasons why loadable doesn't work with federation. But we have come up with solutions for this. They're just not part of the loadable component spec. I don't think that we have a whole lot publicly available about this, but in some of our like federation group repos and things like that, we have kind of developed solutions where you can preload the code ahead of time, or we've got like server-side rendering systems in place now where we render it similar to React server components. We render it on an edge node, and the edge node will return which scripts and CSS came with it. And then we use a similar kind of mechanism where it goes through context, and we push all the chunks up into context and render them out at the top of the app. So very similar to how loadable components like collect or flush chunk extraction works. But the main challenge that we have is that I believe like there's a couple things. Like one is how the Babel processes the import. Usually what they'll do is they'll like give it a name or a magic comment so that they can track down that file elsewhere and kind of push some name into a map. So the problem comes in is when it's a federated import, it can't push the name the same way that it could in a normal Webpack build, because Webpack transforms those modules differently than it would a normal dynamic import. So there would need to be like some special adjustments made in order to detect, is this an exposed module or not? If it is, then don't mutate the name or don't change the import. A lot of places, what they'll do is just they turn it into like a factory object. So instead of it being your dynamic import, it's like an object with like async, sync, and then like a key. And on the server, it runs the require synchronously, and in the browser, it'll run the dynamic import synchronously. But with federation, you would need to have your app set up in a certain way to run that synchronous require statement. You'd have to have an async pipeline somewhere up the application stream to actually do that. So it gets a little bit more complicated there because how the imports are changed, and then also how we don't have access to the actual chunk manifest. So we don't know what, app1/button. We don't know what app1 button is in the compiled chunk because the server isn't aware of what it is either. So that's the big challenge that we have with something like loadable components. It totally can be done. It's just a case that it hasn't been supported by most of the async React ecosystems that are out there.
Yeah, we actually did exactly what you explained in custom code for Wix to support it.
And it's not terribly hard to do. It's just a case that unless there's a big motivation to do it, it's not it just takes longer for these things to trickle into place in the open source areas, especially on something as new as this. And generally, like at a larger company, you'll solve it and you'll probably solve it internally, and contributing it back is like a little bit more complicated. Most of the time, like whatever solutions that we'll put together might be more leaning toward the system that we have wrapped around it, rather than like very agnostic function like loadable components, which works, in a very repeatable way, and it's not very specific to any architecture pattern.
Yeah, cool. So model federation has a feature which is called required version, which actually gives us the ability to use semantic versioning to load shared dependencies. How do you tackle the development experience where people actually develop with one version of a dependency, but in GA, in like production, they get a different version? How would you tackle such an issue?
Yeah, so I think this is a problem that is still not fully answered. What I do is I just use strict versions on everything. So none of my package JSONs have like a caret in front of it. So if they don't have the little caret, then Webpack will enforce the version at its exact number. And then I use renovate bot or something like that across all my repos to keep everything in sync. And the only things um, that I cater for would be like, if I've got like a React version, I already use singleton on it and I set required version to false. So because like if I'm using, say, a Next.js application, I don't really have much choice on what React is available. I can't change it out or anything like that because of how Next is built. So in some of those cases, I just say whichever copy of React is on the page, that's the copy that you're going to have to use, regardless of if it's your version or not. There's no choice. So there is some give and take around that aspect. I would say good end-to-end test would probably be the best strategy if you want to, and trust the symvers that you use, which is harder in the open source space or even internally if you have internal libraries. A patch version can actually change some prop name and end up breaking something, but it's just I think it's just like a risk issue with how we semantically version things. There's always going to be some variance there unless you really want to go for a one-for-one, tightly locked down dependency tree.
Great answer. So how do you see the future plans for model federation? Where do you see this feature going?
I think I would say I could see it helping a lot in orchestration. I've seen some very interesting uses of it, like instead of pulling the data to where the code is hosted, pulling code to where the data is hosted for faster execution. So using federation on the back end to load code into a specific backend where the database is right there instead of loading the data wherever the code is and kind of proxying everything around, which is quite interesting. Some of the other cool things that I've seen used is like with data models where because it's all in JavaScript, you can transmit the data model between different flows, and you can transmit it with methods and with other things on it. Instead of having to like serialize it or use it only as data, you could pass it in and out of other systems with a set of methods attached to the actual data model itself, and then serialize it at some point if you needed to store it or something like that. But yeah, I see some very interesting things in like backend architecture, hexagonal architecture that could be unlocked. For front end, some of the interesting places I see it going would be we'd have something like a runtime lock file. So the ability to change the versions that are used or the nested versions of federated modules used, even control the shared modules. So if you got 3 apps on the page and they're each, say, a different patch version of React, a user interface could be created that says, cool, well, you know, on this app, it consumes these 3 other apps. Here's the versions that they have deployed, and you could go into UI and change which version all of the applications use. Say, you'd make them use React 17.02 from 17.01 and kind of retrofit the dependency graph at runtime, either for sharing modules or for remote modules. I think that'll be a very interesting one. And yeah, I think a lot in the orchestration space is going to blossom. A/B testing as well. Anything to do where you kind of are changing things at runtime based on some decisioning engine or backend. I think there's a lot of room for growth in the marketplace for this type of like, I guess I would say it's an adaptive front end where you could do, you know, imagine chaos engineering or something with the ability to roll back code at runtime. So if you deploy something out as a canary and it starts throwing errors or throws errors in a specific part of the app, you could send a notification or an alert somewhere, and it could immediately roll back the change on a specific app and notify the team of it. So instead of having to create a sev1 or having to actually go and wait for your rollback deploy to kick in, you could immediately respond to, you know, real user telemetry data about what's going on. And if they refresh the page, you could potentially alter how the Webpack runtime starts. So I think there's a lot to be unpacked there in terms of what's possible. You know, I've only played around with this concept a little bit, but I think that it has a lot of potential for how we can roll out code and how we can manage code and distribute it safely.
Cool. I'd like to see that in action. So let's finish off with some inspiration. How would you share with us your insights about future of dev tooling?
Ooh, future of dev tooling. Let's see. That is a good one. I think we're at a place where dev tools are starting to become a lot more important, especially as applications are getting more and more complicated. The importance of having well-integrated tools and deeper insights of your application are starting to become like more centerfold, I would say, especially for scaling or things like that. So I would say like some of the big dev tooling things that like I've gone off and done, just to give an example of this, would be like, you know, developing company-specific Chrome extensions or Webpack plugins that integrate into, say, services about, you know, reporting what our applications are consuming across the board, or, you know, some other aspect like that. And I think that these kind of well-integrated tools are going to be quite critical for managing these growing applications. At some point, they're eventually going to get too large, and we're going to have to start breaking them down into some kind of microservice setup, or whether it's federation or some other ES modules or anything like that. I do think it's going to get to a point where we have to break them down into their own build pipelines. And with that comes a lot bigger need for strong dev tools, better developer feedback loops, things like that. And I think that this is all an area where tooling can definitely grow a lot in. So I also see like dev tools starting to kind of tick over a little bit more into like the low-level languages. So we're seeing a little bit more Rust-based tools. We've got SWC, YesBuild out in the works, and we've seen the performance improvements that those have had already. It'd be great to see a lot more of our build chain tools, things like gosh, I'm trying to think of some good ones. Like, I guess minification would be nice, which I believe is already handled by some of them, but it'd be great to see a lot more of our slower compile tools and build tools begin to leverage these new, like, Rust-based systems. I think that that's still a place that there's a lot of room to grow, is in the speed of what we're doing, and or even just the multi-threading of it. It'd be very nice to see just even JavaScript tools take on multi-threaded capabilities.
Great. So thank you very much for all the answers, and we hope to talk to you again soon.